Hey there, this is your teacher, Miss K's, and we're looking at lesson 11, which has to do with comparing ratios using ratio tables, which to me is kind of fun because then you've got this organized data you can compare. So, the first example, and we'll go through some of this, there will be some things that we leave out or omit, so I'll make sure and let you know. But the first part says, the first example, and this is in your math book, this is page 107. It says create 4 equivalent ratios, 2 by scaling up and 2 by scaling down using the ratio 30 to 80. So, scaling up, the first thing I'm going to do with those is I'm going to, let me just click on this. I'm going to go to the 3 to 8, right? Because what I did is I just took off I divided both sides by 10. So I've got 3 to 8, and then I could also, and this is where I just scaled it down. I scaled it down to 3 to 8. So I brought it down, the numbers down. And so then I could repeat that. So 3 to 8. So then I also have 3 times 2 is 6. 8 times 2 is 16. Okay, so that would work. Okay, and then I gotta go back here. I don't know why that clicks out. I had the same issue before. Okay, 3 to 16, and then at times 3, I would end up with 9 to 24. How many did I need to do? 2 by scaling up, 2 by scaling. I could keep that going. So those aren't the only answers you could have, but those were the scaling down. Then if I scale up, so I'm going to put a little arrow. Those are scaling down. If I scaled up, and I'll go over here, and I could even change. I don't know what that was. Oh my gosh. Let's undo that. Okay. So I'm going to go to a different color. And I've got 30. If I double that, I've got 60. And if I double 80, I have 80 plus 80 is 160. Now, if I triple 30, I get 90. And if I triple 80 times 3, I get 3 times 8 is 24, and then throw that 0 on because of the 10. So there's my scaling up and my scaling down. I'll put that over there. Okay, then it says write a ratio to describe the relationship shown in the table. Well, 2 to 5 to 6 to 10, 16, 40, 6, and that's times 8 times 8 times 8. So what I'm looking at is for me, each of those is, here's a 1, 2 divided by 2 is 1, 16 divided by 2 is 8, so it's a 1 to 8 ratio, which means that there is, every hour, there is, I'll write that down, every hour, it says every hour 8 pizzas are sold. That's what that ratio table tells us. That's an 8. Sorry for my icky writing. Okay. Exercise 1. The following tables show how many words each person can text in a given amount of time. Compare the rates of texting for each person using the ratio table. So 3 to 150. So I'm thinking if I divide that by 3 and divide that by 3, I'm going to get the unit rate. I want that 1 So I'm going to go 150. I think I can do this one mentally. That's 5 and a 0. So Michaela is able to text every minute 50 words. So this one, I'm going to divide for Jenna, divide by 2, divide by 2. So I'm going to get my, in a minute, how many texts, how many words can Jenna text? I'm going to get my 90 divided in half. I believe that is 45. So Jenna in a minute can text 45 words. And Maria, nice name, divide by 3 to get it down to per minute. So 120 divide by 3, there's a 40, okay? So let's see what we need to do with those. So we've got all of their rates per minute, right? And then I'm going to go, I flip over to page 108. And here's the thing with 108. I'm going to go to the next page, but I have all my work there. Let's see. I'm going to enlarge this just a bit. It says complete the table so that it shows Max has a texting rate of 55 words per minute. Okay, so I'm going to go back to my blue. So it says on his rate, I'm going to go in a minute. We said that was 55, right? Okay. So if I double that, what's 55 times 2? 55 times 2, I write it right over here. 55 times 2 is 110. I just doubled it. Okay, what about if I 1 times 3? What's 55 times 3? Or I could add 55 to 110. 15, 165, 165. Okay, how about 1 times 4? And so it's 55 times 4. 0, 2, there's 22, 220. Wow, that's a lot of words. Okay, so exercise 2. Making juice, comparing juice to water. The tables below show the comparison of the amount of water to the amount of juice concentrate. You know, like you get the juice concentrate in those cylindrical cans in the freezer section of the grocery store. In grape juice, made by 3 different people, whose juice has the greatest water to juice concentrate ratio, and whose juice would taste strongest, meaning the juice would be really strong because they did not add that much water. Okay, so I've got this much water to this much juice concentrate. So what I'm doing is I'm looking at these. I'm going to put in a 1 because I want to divide 4 by 4 to get 1. So that means I'm going to divide this by 4 and I get 3. So they put in 3 cans of water to 1 can of juice concentrate. Now, and so then that would be 4. Okay, here, this is, so divide by 2, divide by 2. I get 1 for my juice concentrate and I get 5 cans of water for 1 can of juice concentrate. So divide by 2, divide by 2, I get 1, and that one is 4. Okay, so now it says put the juices in order from the juice containing the most water. So that's going to be Franca's with 5 cans of water. So Franca has the most water to the least water. So then next is Milton with 4. And then we have Laredo with 3. They explain how you use the values in the table to determine the order. So we divided each juice concentrate by a number to get a single can can and found out how many cans of water were used. Okay. So what ratio was used to create each table? So Laredo's, I'm going to go back to those numbers, was a 1. And actually I could reverse that 3 to 1, but now that I've written it. Milton is a 1 to 4. Franca is a 1 to 5. Okay. So, and a lot of you, you know, you're using either multiplication or you're using the unit rate. So we got that one done. So we are going, explain how the ratio could help you compare the juices. Okay, that's at the top portion. We're gonna omit this one, but explaining how the ratio can help you compare the juices. Well, that unit rate, let me get to where I'm at. I'm just going to write the unit rate helps us determine number of cans of water. Okay. Are we so? Yeah, we're going to omit this. So you don't need to do B. If you want to do it, if you're on a roll, then do it. Otherwise, don't worry about it. And then I'm going to go to the next page, 4, and I'm going to omit. I'm going to not do this, and I'm not going to do this. So if you're not watching this video, I don't know what to tell you. Okay, then we go to the lesson summary. Ratio tables can be used to compare two ratios. Got it. Check. Look for equal amounts in a row or column to compare the second amount associated with it. So, and I can also, I divide by 3, that's going to be trouble. Okay. How about if I divide by 10 to get 1? The values of the tables can also be extended in order to get comparable amounts, okay? Another method would be to compare the values of the ratios by writing the ratio values, the ratio as fractions, and then the knowledge of the fractions to compare the ratios. Yeah, sometimes for me, the lesson summaries are really, they use a lot of words. They don't need to, but that's okay. When ratios are given in words, creating a table of equivalent ratios helps. And I love, when I get a lot of words, I draw a table. 12 to 35 compared to 8 to 20. Okay, remember it's just a sum, so we're good there. Then here's the problem set. And I know we've got class set video, we've got problem set video. I want you to read through the homework helper. I'm encouraging you also with this week to work on Khan Academy at least 20 minutes for the week. I know that's not a ton, but I want you to start in on the LearnStorm and also some ratio work. So let's take a look at this problem set. This says, Sarah and Eva were swimming. And it says, use the ratio tables below to determine who the faster swimmer is. You've got either Sarah or Eva. And in 3 minutes, they can swim 75 meters, not laps. Oh my gosh, that would be insane. And Eva, 2 minutes, it takes her to swim 52 meters. So I would say, for me, looking at this, I would say you've got, for Sarah, I want to find out what she can do in a minute, right? So I would take, that's divided by 3. That was divided by 3. So 75 divided by 3, there's a 2, and then there's a 6, and then 15, and so there's, 5. So there's in 1 minute she can swim 25 meters, which is like the length of the pool. That's good. And then so for Eva, I'm going to divide that by 2 and divide that by 2. So what is 52 divided by 2? Well, 2 and times 2 is 4, 12, 6. Oh my gosh, isn't that hilarious? They're so close. I would say we divided to find we'll say unit rate. That's what we're doing. And so, but I didn't answer the question, did I? Who is the fastest swimmer? Okay, so in 1 minute, she can swim 25 meters. Eva can swim 26 meters. So Eva is the faster swimmer. Or I could say she's the fastest. Okay, so that answers the question. I always want to make sure I answer the question. Then the next part of the question says, this is 120-pound person would weigh about 20 pounds on the Earth's moon. A 150-pound person would weigh 28 pounds on Io, a moon of Jupiter. Use ratio tables to determine which moon would make a person weigh the most. That's kind of an interesting question, isn't it? So, 120-pound person. So I'm going to just go pounds, and then we've got on the Earth's moon, and they just said that was 20. So right there, even I can get rid of the divide each side by 10. Okay, so here was pounds, and then I'm going to go IO. So it was 150, and then this one was 28. Okay. So for this one, I want to first divide. Whoops. I want to first I want to divide both sides by 10. So now I've got 2 to 12. You're 12 pounds on Earth and 2 pounds on the moon. So then I'm going to divide by 2, and now I'm going to get 1. And over here I'm going to get 6. What is 12 divided by 2 is 6. So if I weighed 6 pounds here on Earth, on the Earth's moon, I would only weigh 1 pound. And now when I'm over here, I have, so 28, I'm going to divide it in half first. I get 14. Divide this in half. So what's 2 divided? So I've got 150, 2, 7, 14, 1, 0, it's 5, so 75. Well, can I divide this again? Divide by 2, I get 7. I wonder if you know what, let me just try, well, I'll do this again. Divide by 2. So 75 divided by 2 is 3. 15 is 7. So 37.5. Okay, so now I'm going to divide by 7 to get my unit rate, just to see what I get. So there's 1. And then what is 37 and a half divided by 7? So 7 times 5 I know is 35, and then 25, and put my decimal, is 7, 21, 4, 0, 6, 5. Okay, so someplace close to this. You know what? This is really close. So use ratio tables to determine which moon would make a person weigh the most. So if you weighed on Io a pound, this is what you would weigh on, this is what you weigh on Earth, this is what you weigh on Io. If you weigh this much on Earth, and we want it, so which moon would make the person weigh the most? So here, this is a little bit of reverse, but you don't weigh as much here, but you weigh the same on Io. So I'm going to say a person on Io would weigh more than a person on our moon. Because this one is a different, so we've got 1 pound on the Earth's moon, but you weighed 6 pounds on Earth. So this one, you're lighter here, but you weigh more on Io in comparison. To me, that's a little bit confusing, but I think we're done with that. And then you want to make sure and look for the exit ticket. I am going to, so exit ticket is going to be a Google form, and I will attach it. So make sure and look for that. And I hope it all works out well. So congratulations on finishing yet another lesson. You are awesome.